build it so that it has a vertical asymptote, a certain hole, and a certain horizontal asymptote. Then find the coordinates of the two holes. Oh, it has two holes. So when you're building a rational function, basically you're building the factors that are going to make this true. So my function always starts out as y equals. So let's hit this in order here. So how do I build a vertical asymptote at x equals 3? What factor do I need down in the denominator to build that vertical asymptote? X minus 3, right? So that when I plug in 3, it's undefined in the denominator. So if you have an asymptote at x equals 3, your original factor was x minus 3. How do I build a hole at negative 2? What do I need as a factor? X plus 2 over x plus 2 so that they will cancel and make a hole. All right, so I did that part. How do I make a hole at x equals 0? You could write x minus 0, or you could just write a factor of x over x that would cancel itself out. All right, does it satisfy that third qualification? Would this function have a horizontal asymptote at y equals 0? Why or why not? So as is, can I leave this as my function? Does this have a horizontal asymptote at y equals 0? Yes, why? Yeah, so whether I look at it in this form or if I think about canceling these two factors out, the denominator will still be higher in power, so I'm good. I don't have to do anything playing around with the powers. If they'd wanted a slant asymptote, you would have had to like increase the power of the numerator. If they wanted a horizontal asymptote at 5, you would have to make the powers equal and add a coefficient of like 10 over 2 or 5 over 1. All right, so if this is my function, how do I figure out where the holes are going to be? What I do is I think about my new function, right? This is the answer to the problem because this has the holes built in. But this 1 over x minus 3 is the function that I use to calculate the holes. Because I think about canceling these factors out, I would have 1 over x minus 3. So I can plug in negative 2, see what I get. And I can plug in 0 and see what I get. So plug the two x values into that function and see what you get. That way, if you have some time after the quiz, you can try the back page of this kind of on your own for practice. So when I put in negative 2, I would get negative 1/5, right, as my output. So at negative 2, negative 1/5, there's a hole. If I plug in 0, I get negative 1/3. So 0, comma, negative 1/3 is the other hole. Does that make sense? On the quiz today, you don't have to build your own function, but on the test, you might have to, or I'll give you a graph and you have to build the function using the graph, the asymptotes. All right, so let's do one more kind of with holes as practice. So it says graphs of rational function include intercepts, asymptotes, and holes. So I need to factor first so that I can cancel, right? So I've got, this is already in factored form, but this is a quadratic. So how does this quadratic cancel and how does my denominator factor? Why don't you use the diamond for a second? See if you can do the diamond, factor the numerator, use difference of squares, factor the denominator, cancel it out to get your new function. And then we'll make sure we have the correct function before you answer all the parts. So one factor should cancel. So did we get at least to our new equations over here? So we have x plus 5, x plus 1 in the numerator, over x plus 3 in the denominator left. I wrote it out for myself so that when I start doing division, I remember to use standard form in the numerator. So why don't you use your note card, see if you can successfully finish this problem, and we'll go over it in a minute. Make sure to find your whole, because you did cancel something out over here. If you don't understand how to analyze the function, I can do that with you in a minute. But I'm going to give you a couple minutes to try it like this is, your... All right. So here was my, let's see, my y-intercept was at 5/3. I had two x-intercepts at -5 and -1. My vertical asymptote at -3. And then my slant asymptote, you have to use standard form for your dividend to do your division. So x plus 3 ends up being your asymptote. So you start at 3 on the y-axis and go up 1 over 1. And that actually nicely divides your two sets of points. So this curls towards the two asymptotes, and so does this one. So you have two big elbows. The whole was a little bit tricky to plug in. You had to plug in the number +3 because that's what made your original asymptote or undefined value that you canceled. So you plug +3 into either your new function in factored form or your new function in standard form. So this number was a little bit big, I guess, without a calculator because it was the number 32 divided by 6, which is 5 1/3. So I had to bend my elbow a little bit closer to reach 5 1/3 as the whole. But if you got a hole like way over here, that should be like a red flag. Your asymptote needs to get, or your function needs to get closer to the asymptote. This analyze part, as x goes towards positive infinity, what is this side of the graph going towards? Positive infinity, right? The y values are going up and up and up and up. This one says as x gets closer to your vertical asymptote, right, -3, what is the positive, the right side arrow doing? So they're talking about that arrow. It's heading towards negative infinity as a y value. So we're going to start to see this notation more and more throughout the year, but I'm not asking you it today. I don't even know if I asked it to you on the test. I think the test I asked domain and range questions, but not analyzing questions. No. No. On the quiz, it's